start. I can see that some people have uploaded the workbook already, and that's fantastic. If you haven't, remember, I'm not intending on making any kind of late penalty until we get after the 26th anyway, and even at that point, I'm probably not going to be too strict on it. What I would advise is that if you are procrastinating on it, get it tidied away as fast as you can achieve. So it takes a little bit longer, something's got in the way, and it's delayed you a wee bit, that's fine. But keep plugging away at it as much as possible, because today I'll be issuing you out your first larger assignment, your first kind of bigger program, and then next week you get your second workbook. Now, the assignment I'm giving you out today will be due for the first week in December, so you have roughly 2 weeks to complete it. The workbook is due when we come back in February, so there's a little more time to work on that. The workbook will be very much like what we've done so far, where it's just going to be small questions. The assignment will be large ones. We'll talk about that later on. What I want to do today, last week we did an introduction to strings, and we did about 7 questions on it, just messing around with what could we do, what type of manipulation could we do with strings. And what I want to look at today is I have released other worksheets, which I probably should have released before this. They're not graded at all, there as practice questions. But my intention for today is to work down through, there are 4 questions on this, to work down through the 4 questions. If you have things that you want me to go over, if you have things you're not 100% on, then we'll have a look at that. But we'll get through the 4 questions. If everybody's happy with the 4 questions, then what we'll do is we'll do I can't remember, last week did I give you a question where the user enters in a string and you count how many times the character E occurs in that string? Okay, we'll do that as our 5th question then. And then after that, we will look at the assignment. If everything goes really smoothly, the break will happen, we'll come back, then we'll look at the assignment, and the remainder of the lab will then be for working on that and asking questions on it as you're trying to get your head around what I'm asking you. If not, well then we'll do probably the 5th question, the count how many times E occurs in the string, when we get back after the break. Okay, so for this worksheet, we need to bear in mind that if we were to take user input, however, all of my solutions are going to ignore user input to keep it nice and compact on the screen. But if we were taking user input, we're taking input from a string. We're going to use the next line command, but irritatingly, there isn't a next char command for taking in a single character. So the way we have to handle that is we take in a string, and then we just get the character at index 0. In other words, the first character in that string. If you ask the user for a character, you'll assume they'll only enter in 1 character. But just in case you decide to write a large essay, when you ask for a single character, it'll take the first character, and that's what it's going to store for you. Fair enough? Okay. So let's have a look at question 1. Question 1 is going to ask me to, or string 1. Create a program to compare 3 letter or character variables and output which is the largest. So in other words, I'm going to create 3 character variables here in my code. I'm going to have some sort of an expression to evaluate which one's larger or which one's smaller, and I'll tell you which one is larger, which one is smaller. Before I do this, is there any, or before I kind of just dive headline into the questions, is there anything from last week that anyone's a little unsure of that you want to get clarification before we start looking at these examples? Everyone's reasonably happy? Okay. Right, so if we were dealing with numbers, compare 3 numbers and output the largest, it's a really trivial problem. Because we've been doing this since week 3. Comparing numbers is 5 larger than 7, is 5 equal to 5, is 7 less than 19. We've been doing those type of comparisons very early on in the course. And once we started introducing variables, then we can say, is variable x less than variable y? Is variable x equal to variable y? The last question that you did in the worksheet that you handed up, or you were due to hand up, asked you to check to see, have you guessed the number correctly? So you're saying, is the user's input equal to the random number I've generated? And if it's not, you're going to work out, well, is the user input greater than or less than the random number I'm trying to guess? And then you can prompt the user, you need to guess higher, you need to guess lower, to allow the user to get faster to whatever goal point they're going for. So when we're dealing with numbers, this is a very trivial problem. So if let me very quickly write it out as a numbers problem, and then we'll convert it into characters. So I'm going to create an integer variable here called first, set that equal to a value. Another integer variable there called second, set that equal to a different value, and a, as you might imagine it, third integer value set as something else. And then what I would have here is I would have an if statement that would say if first is larger than second and first is larger than third, then we could comfortably say that the first variable is the largest. Okay, so that makes sense. If first is larger than second and if first is larger than third, we can say, well, whatever that value is, that's going to be the largest. Otherwise, we do the same evaluation for second. So if, just copy that there, if second is larger than first, and if second is larger than third, we can say that second is the largest. And you're probably going to guess where we're going with this. So if we were doing this question just with numbers, well, we would have done this weeks ago, because we have very manageable code here. We have 3 integer variables, first, second, and third. I've given them values. So immediately from looking at that, your understanding of how numbers work, you can say, oh, well, second is going to be the largest, and first is the middle, and third will be the last one, the lowest number. But just to make sure that the code understands or works the way it should, we have our evaluations done here. We have our, to make sure, well, is it larger than this, and is it larger than this? Or is second larger and second larger, or is third larger and is third larger? And that's dealing with integers. Now, clearly, characters aren't integers because we've got alphabet, we've got symbols, we've got lots of other stuff. But interestingly, and you may have covered this already with Paddy in computer hardware, everything in a computer relates back to numbers. I was trying to find an image I generally use. And I usually use this one. Eventually it's coming there. Okay. So when we look at computer hardware and you look at the smallest possible incremental value, we're looking at binary, or from the hardware point of view, from the circuit point of view, positive and negative voltage. And from that we can get ones and zeros, and from that we can get our binary code, which then we've learned how to convert into octal or into hexadecimal or into base 10 as decimal code. And once we have it in base 10 in decimal code, we have this numerical reference, which we're used to. And so what has been created over time is what's called an Ascii table, which is going to be how I can relate any character on my keyboard, whether they be non-visible or visible characters, and present that as a numerical lookup. So if I type the letter A on my keyboard, it goes off, and it goes to say, okay, that's lowercase a, that's going to be 97, and it has a code to represent, oh, that's how I represent it on the keyboard. If I typed in full stop, well, then that's going to be 46. If I typed in ampersand, it's going to be 38. So this is a very useful and interesting table. We do not need to remember really any of it. There are a couple of things that will help you remembering, or will help you in solving problems. The general rule is that capital letters occur before lowercase letters, and that will make more sense as we do other more complicated problems. And When we're talking about numbers, remember we're talking about a character, single key press. So we're talking about a numeral. If you've got the number 25, that is 2 characters. And so we need to be aware of that as we are going through our solutions. Sorry. So that's all you really need to remember. Everything else we can work out. If you're in a class test or an exam and I ask something about the numerical value of a character, you can write a very small piece of code that will convert it. Will convert a character to a number and vice versa. So it allows us to do a lot of stuff there. We'll see that in the second question we'll look at today. But what's worth noting here is that because I have a numerical lookup for any character I can type, if I enter in an alphabetic character, so if I enter in A and I enter in L and I enter in Z, and I do the same comparison, is A greater than Z, is A greater than L, I don't need to do any type of conversion at this point. The Java virtual machine is smart enough to say, oh, Z, you're converting, you're comparing one to the other. The easiest way of doing that is get the numerical lookup and see which occurs first. So for converting my numerical problem into characters, I need to make 6 changes. I need to change int to char in 3 places. And I need to give it character values because that isn't a character value, it's a numerical value. So I'm going to say here, lowercase a, here I will do Z, and here I will do Y. Okay, so now we have a piece of code where we have character variables, so we're comparing 3 letter type variables, which have character values, but everything else in our code can remain exactly the same. We can treat the comparison of one character to another character. So when I say comparison, I'm talking about less than or equal to, not equal to, greater than or equal to. Any of those 6 comparisons, I'm talking about using those. We can treat it as if it were numbers. We're comfortable with how to compare numbers. So it's a small extension of that to be able to compare characters. But the same evaluation is going to happen. When I have first here, it goes off, it replaces that with the character A, and the second here, it goes off and replaces that with the character Z. It then flicks out to my Ascii table and goes lowercase a is going to be 97, lowercase z is going to be 122. 122 is bigger. So the first part there is 97 larger than 122. No, it isn't. That's entirely false. Move on to the next one. Is 122 larger than 97? Yes, it is. Is 122 larger than, well, I need to go off and look at y. Lowercase y here is 121. Yes, it is. 122 is larger than 121. So it comes in here and I say z is the largest. And it won't bother running the last one. Okay, so let's test that just to make sure it does what it's meant to do. So I'm going to go see desktop. There, Java C strings 1. Then Java C. Nope. No. Just Java strings 1. Strings 1. That's going to tell me Z is the largest. What's nice about this is that now that I have this lookup table here, I'm not restricted to just alphabetic characters. I can change the case. I can say this can be uppercase Z. Same happens. We go off. We look up here. Uppercase Z is now 90. Which means that if it's 90, well, then 97 is going to occur after that. So A is larger than Z in this scenario here. And Y at 121 is going to be larger than A. So it'll say third is the largest. So if I save that, what am I saving that for? Right, save that code. I haven't. Save. So recompile. Run again. It'll tell me Y is the largest. I'm not restricted to alphabetic characters. I could put in value in there, I put a Z in there, I could put a percentage sign in there. They're all still typable characters, so I can save that, recompile, Run again. It'll tell me capital Z is the largest, because if I go back here, I have the number 8 and a percentage sign. Well, the number 8's numerical lookup is here. It is 56. And percentage sign is 37. So that's how we're doing our comparison. For most of the examples I give you, we're comparing alphabetic characters. And I usually, so if we did something like a Caesar cipher, which the next question is kind of like a mini version of that, we would be able to just restrict our searches to within the uppercase alphabet or the lowercase alphabet or 32, the space character. And we could ignore every other symbol and not alter it. But this is valid for everything from 32 up to 126. It's actually valid for even more than that. But the problem is these are non-visible key presses. So it's very hard to actually get some sort of output or to print out from that. So I usually stick between 126 to 32 because they're all the visible keys on your keyboard as you would type. Okay. Does that make sense to everybody? Let's put in some quick comments on this. This is ASCII code 56. This is ASCII code, can't remember, 90. And this is ASCII code 37, I think. Yes, 37. So it just gives you an idea when you're looking back about where those numbers came from, why we're doing that comparison. I've been teaching first year programming for years. I generally remember that space is 32, uppercase A is 65, and lowercase a is 97. And like anything that's relevant, I can work out from those because I know that if I know what uppercase A is, I know what uppercase B is, I know what uppercase C is, I know what uppercase Z is because I can calculate it by the position in the alphabet. But even if I don't, if I didn't know what it was, I could, and we'll see in the next question how we do it, I could just say, well, convert that to a number and tell me what the number is, print out the number. And so I could work out what those numbers are. If I was doing a pen and paper examination, like your class test or like your exam in May, I could write code to store the value as a number and then just use numerical checks, addition, subtraction, multiplication to be able to work it out. The problem we're going to have is making sure that when we're dealing with numbers, that we restrict our range to somewhere between 32 and 126, because otherwise, I mean, think about it. I have roughly 96 possible characters I can type there, but our integer value goes from minus 2.4 billion up to positive 2.4 billion, which is far, far greater of a range. So I need to make sure, and you will see when we go to the next question, how I'm going to implement it first, that it's going to give me a lossy conversion. Basically saying if you convert directly from a character or from a number to a character, you might lose a whole load of information because it was truncated to the ASCII table for you. Okay, everyone happy enough with that? Make sense? Anyone got any questions before I move on? No. Okay, that's the first question. Second question. So the second question is create a program that will increase the letters of your name by 1. So for example, if my name was Owen, well, it's going to increase it to FBJO. Because if we were to go through this and we look for, I have capital E, so capital E, I'd go to obviously capital F, which is there. If it's O, then O will go to P. If it's I, then I is going to go to J. And if it's N, then N is going to go to O. So it increments it forward by 1 in the alphabet. So how would I do that? Well, I'd first of all create a string S equal to my name. And I probably want to store the name, the output. So actually, let's not call it S, let's call it name. And here we will have string new name. And set this equal to an empty string. I'm going to have a loop, so I'm going to need to have a counter. 0. And for the moment, that's all I need. So this is the value or the text that I'm going to amend. This will result in the output, whatever I want to print out. And so at the very bottom here, I'm going to have a system.out.print ln new name. Just so we can see what the output is there. If I have this here, I probably should print the original name at the top. And my loop is going to go in here. So my loop is going to be a normal string loop, which means I'm going to start at 0. That's where my counter is. I'm going to keep going while my counter value is less than my string length. Okay, so that's the exact same as what we did last week. This is a loop that's going to go from the very first character all the way to the very last character, checking every single character as we go through. My last line of this is going to be counter plus plus, and that just basically says that I'm going to move on to next. Character. Good Lord, I can't type today. Character. Okay, so what am I going to do? For every character that I get, I want to get the character out of the string. That's my car C is equal to name.car@counter. We had that last week. And I want to add 1 to that character. So I'm going to have something along the lines of this. I'm going to say car C is equal to name.car@counter. That will get me my current counter. Current variable. I'm then going to say new name is equal to new name plus C plus 1. So what's going to happen in that line there, line 14, is I'm going to take my existing value for new name. I'm going to take my current character and add 1 to it. So if it's an A, increase it to B. If it's a B, increase it to C, and so on. And truncate that, or not truncate, concatenate it onto the end of the string. So I'm going to build up my output string 1 character at a time. I hit the first character of my original string, I shift that letter up by 1, add it on to an empty string. And then I do it for the second character, and the third character, and the fourth character. They all kind of slide along. I have this in brackets to make sure that it's going to do this calculation first and then add on my values there. And then I move on to the next character, and I keep going until I hit the end of the loop. And at the very end, I'm going to print out whatever the results would be. So I should get FPJO as my name. Okay, so Java C strings 2. Then Java strings 2. And so my original output is Owen, and my next output then is a huge number. So we have a problem there. That's a bit of an issue. So we need to fix that. Well, first of all, let's figure out where that number is coming from. I have 70112106111. It's a bit of an odd number. But if I go back and have a look at my Ascii lookup table, capital E is 69, so F is 70. That's where the 70 comes from. The next character we're going to get is P. So then we're going to get 112, which we get there. So we have 112. And then we have 106, which gives us the J, and 111, which gives us the O. So it has taken the character, and because you have character plus integer, it goes, oh, I'll make this the most common, the most common denominator, which is everybody's an integer, converts the character to a number, adds the number onto it, and then just adds those digits onto the end of the string. And that's why my output looks like this. I don't want that. I want characters. So what I need to do now is I need to force my value. I need to force my value from a number to a character variable, and then I can add it on to the string in the same fashion. So the forcing from one data type to another is called casting. You can't do it to every data type. You can't create, let's see, what's an example? I couldn't create a double and then convert it to a, well, I suppose I could convert it to a string. It's not as simple as just, oh, we'll make that a character, we'll make that a string, make that a double. It doesn't work as simply as that. There's usually a little bit more information working in it. But because characters and number, or characters and integers are so closely related, we can just say, we put a little bit of an extra command here that says force this to become a character. So I'm going to do it on 2 lines just to show you how it works. So here I'm going to say C is going to be equal to okay. And then here I just need plus C. Okay, so this line here, line 14 now, I'm taking on the left-hand side, or on the right-hand side here, I'm taking the current value of C, my numerical lookup, and I'm adding 1 to it. So it takes, to begin with, it takes 69 and adds 1s to it, and it gets 70. And then what happens here is I have the data type I want to convert it to, or cast it to, in the brackets, and it's going to force the conversion from 70 back to a character, which means we do the lookup backwards. We go down to 70 here. We'll go across to our red column, the little characters, and say, right, that's what it's going to be. And it converts it to a character. And then we just add that character onto the end of it. So by doing that one extra step in line 14, we are going to change our output. Rather than having input of string and an output of a kind of a weird collection of numbers, we're going to have an input string of characters, of alphabetic characters, and an output string of alphabetic characters. So you can see then that I get the correct output there. And if I were to change that completely, so if I were to change it to a much bigger string, it does the same action, but it applies it to every single character, so spaces and all. So you can see that the original string was Owen Carroll as my name, and I spelled my own name wrong. That's a great sign. And then what has happened here is I've converted each of them. But you can see that we have an exclamation point, an exclamation point, an exclamation point. So the next character after 32 for space is 33, which is for an exclamation point. That's why we have those there. But it gives you an idea of how it's going to work its way through. Well, switch. How it's going to work its way through each of the characters and say, well, okay, let's move it up 1, let's move it up 1, let's move it up 1. So I'll revert that back to a neutral. Okay, that's the second question. Does that make sense to everybody? Anybody have any questions on it? If I were to take this and amend it slightly, so rather than, see here, I've hard-coded my value, so I'm only going to increase it by 1. I could amend this code to allow the user to enter in a specific integer value, and it would shift up the letters in my name by that value. So it would move it up by, well, I suppose if we were going with the alphabet, we'd restrict our number to be somewhere between 1 and 26. But we can shift up the value by whatever the user would define. And if I did that, and if I only paid attention to alphabetic characters, so I only paid attention to 65 through to 90 or 97 through to 122, and any other characters, spaces, exclamation points, quotation marks, brackets, I just left as they were, I would have implemented a very basic Caesar cipher. So Caesar cipher is a really rudimentary encryption scheme where you take the letters of the alphabet and a number and you shift all the letters up by that number to make the text illegible. And then to decode it, you do the reverse. You take the number and you move back up the alphabet, whatever number that was. And this was an encryption technique that was used by Julius Caesar to send messages from one camp to another camp without people being able to intercept them and read them as they go along. Obviously, encryption's come a long way since then, but it was simple enough that the code took long enough that it made deciphering it, not deciphering it difficult, but it made it timely. It took a while to do, which usually meant whatever the message was had expired at that point. But we have almost the Caesar cipher here. If we were to, like I said, allow the user to define what number it is here, and allow the code to ignore things like spaces, full stops, it would allow us to encrypt and decrypt our code in the same way.
If someone did put in like 1,000, would it just not keep like print out anything?
Put 1,000 here?
Yeah, like would it print out anything?
Let's find out. That's what you get. Question mark, question mark, question mark. Because rather than having 70 be the next number here, I have 1069, which is far, far beyond the end of the Ascii table. The Ascii table ends at 127. It goes from 0 to 127, so there are 128 valid inputs. Anything above or below that number, it does not know how to deal with it, so it gives you either a question mark or sometimes it gives you like a square box. It usually just means it's an invalid character. We want to make sure that if we're dealing with this, that we are making sure it's. Yeah. Now, what we could do is we could make this far more complicated than it needs to be. We could create our integer here. Caps lock, so int is equal to 1,000, and then you can say num is equal to num modulus 128, the number of valid numbers on the Ascii table. And then here, you just have num. And so what that would mean is if someone entered in 1,000, 10,000, 275 million, it would restrict back down the range to be somewhere between 0 and 127. So if I'd save that and now I run the same code, so now I don't get the same output, but I do get an output where there's a valid print character for each of my outputs. Fair enough? Okay. Everyone happy enough with that? Any questions? Let me get rid of this stuff here. What I would say on that question, where you just have an idea, hey, I wonder if I put in 1,000. If you get it working on one number and you're wondering what happens, go check. Obviously, this example here, I'm working through the example, so it makes sense to ask me. But if you're working on a problem at home and you go, I wonder what would happen if, change the value. Keep a note of what you changed so you can revert it back if it does something crazy. But the best way to learn how code works is to break it, to see how far it can be pushed in one direction or another before it stops working the way you expect it. And if you can work out why that's happening, that's even better. Because then what you've done is you've figured out, oh, I know the boundary of this functionality, and I know it's there because, well, the Ascii table only has 128 values. Or because you can't directly convert, or you can't directly add a character and a number and keep it as a character. It gets converted to a number because it's the lowest common denominator. Everybody happy with that? You guys are super quiet. Is it the nerves that I said there's an assignment coming? Okay. Okay, so that's question 2. Question 3 was to create a program that takes a string in from the user, and if the length is greater than 10, to print out double, and otherwise we're going to print out single. So in other words, if it's 1 to 9 or 0 to 9, we're going to print out single. If it's 10 or above, it's going to print out double. So single digit, double. So we're going to have our string here. String S, and we'll give it a value there. Let's go hello world. Okay, and that clearly is larger than 10. So 2 5-digit words or 5-character words with a space in between. So what we're going to do is we're going to create an int here called length, and that's going to equal to s.length. So we usually use s.length to define when have we got to the end of our string. And we know that because what it does is it goes off and it counts how many characters we have and it returns back whatever that value is. So here we're going to do the same command. We know what s.length is going to do. It's going to tell me how many characters are in this string s, and I'm just going to store it, so I don't need to recalculate it each time. And then I have my if statement. If length is greater than 10, then we are going to print double. Otherwise, we're going to print single. Okay, so that's very simple. It's going to count the number of characters in the string, whatever string we have here. If it's greater than 10, it'll print out double. If it's 10 or less, it'll print out single. Okay, excellent. I have some weird character. All right. So nothing to do with my code. It just doesn't like the quotation marks in Word. We do still have a lecturer who teaches web development to full-timers, and he used to on purpose leave in all of the Word quotation marks in his code so that no one, the student, would copy and paste. You know what would help if I actually ran the program I want to run? There, strings 3. There we go. So it's going to print out a double for that because Hello World has 11 characters. If I change that just to hello, it prints out single. Very, very simple. That's, again, we have taken a string input and we have reverted back to a numerical reference to make our life easier, to deal with something that allows us to make it easier, because we go with what we're more comfortable with. When you're doing these problems, one of the key ways of getting them solved is, well, how can I relate this to what I'm more comfortable with? If I give you an assignment, and I'm giving you an assignment that's going to relate to strings, and it's going to encompass variables and user input and system output and if statements and loops, and that's fine. But strings what the focus is. So you have to look at that and go, well, how do I make this simple for myself? How do I get the bits I know how to do, incorporate as fast as possible? When I give you your second take-home assignment, which will be in the second semester, it's going to relate to arrays. But it's also going to encompass output, input, variables, if statements, loops, probably strings in some capacity, and arrays and methods. So you start checking off the bits you can do more comfortably. And in the assignment, I'm sure you've discovered this from other modules as well, the assignments are meant to be a challenge at the point you get them, and they're to be a challenge while you still have them. And usually a week or two after you've handed them in, you can look back and go, why did that take me so long? And that's good. If that's happening, that's the ideal point, because it means that you're learning from the the process of having to do the assignment, of being forced to do whatever piece of work it is. And if you're looking back and going, oh yeah, that really should have taken me 2 weeks, or why did I have to pull an all-nighter on that, or whatever it might be, that's good, because that means that your skill level and your competency has moved forward in the time between getting the assignment originally and wherever you are now. Okay, everyone happy enough with that one? Right. So that's not that one. Now, we are going to create a program to take a string from the user and check it against a password variable. Now, as I'm seeing this now, I can see I've got word quotation marks in there, so I need to get rid of that. That, and that. Why is it okay? Right, so we're going to check the equality of two strings. Now, here is where we can't really convert it back to the numerical reference. If it was numbers, it'd be really simple. Take an input in from the user, store that in one string, have your password string hard-coded somewhere, and you just do string 1 equals string 2. Unfortunately, that's not how strings work. If you remember last week when I was introducing the idea of strings, I said pay attention because the word string is our first variable that begins with an uppercase letter. All of the other variables we used so far, integer, double, boolean, character, char, they all begin with lowercase, so they are defined as primitive variables. The string is a collection. It's an object, which is a complicated variable or a complex variable. It's got extra stuff it can do inside it. But one of those things, which you'll learn about next year in object-oriented design, is it inherits from the object class, which means what it means is to check for equality, there's a specific command you need to use. You can't just go equals. And so that command we're going to look at in this one here. So I'm going to do that space there, only that. Here I am going to say string input is equal to, this is what the user would supposedly enter in, but I'm not having the user input in my program. Let's go with password. Let's go with password spelled correctly. There. And then string password is equal to, and let's say password here should have been with one uppercase letter and with one numeral. And when you start to sign into a web form now, they tell you it must be between 8 and, I don't know why they set an upper limit on passwords. Usually it's between 8 and 14 characters. It must have an uppercase character and a lowercase character, and it must have a number. And then they sometimes say, and a symbol. And if it's Apple, and none of the passwords you've ever used before. And I have seen other ones where they start checking for dictionary words in it. So they'll check through the substring and go, oh, well, that's a word in the dictionary. You can't use that. Or that's a word in the dictionary, you can't use that. So they're getting even more advanced now so that you have to have ridiculous passwords. One really good cheat for passwords, apart from using something like a password manager, is pick the password you want. Water bottle mouse, that's my password. And have a look on your keyboard. And if you were to move all of the keys you typed, one to the right-hand side or one to the left-hand side, you are left with an unintelligible password, but you know how to recreate it. That's a really quick way of creating an incredibly secure password, because someone will look at it and go, that's just gibberish. Or you pick a quotation from a book, like a long 70, 80 character long quotation. If you have kids and you have spent the last couple of weeks reading the same story as a bedtime story, there's probably lines on kids' books which are embedded in your brain at this point. Okay, right. So we have our password the user would enter in. And we have the password we want to check against. There. And this is very simple. We don't need a loop. We don't need anything but an if statement. We're going to say if input dot equals. P word. So in Java, because it's part of the way it's designed, if we want to compare one object to another object, so in other words, for first here, if we want to compare one string to another string, rather than using two equal signs, we need to have the dot equals where we send in the other thing we want to compare inside the brackets. And that will still work the same way our double equals goes. It gives back a true or false response, which we then can use. So if they enter in, if the password equals, well then we're going to say system print ln. We just put in here, we put in access granted. Otherwise, we're going to say, we'll just say there, invalid password. And semicolon there. Okay. So that's our very basic program. It's not a complicated program. It's only there to illustrate that if we want to check for equality, we use the dot equals command. Dot equals will not work with an int or with a double or with a character or with a boolean, but it will work with a string and vice versa. Double equal sign will not work with a string, but it will work with an int and a double and a boolean and a character. And any other data type we end up using. Everyone happy enough with what I've done there? Yeah?
Can I ask for something?
Of course you can.
Why in the comments you put the dot asterisk and the...
Okay, so if I have a single line comment, I just use 2 forward slashes.
Yeah.
Okay, if I have a multi-line comment like the top, I start it off with a forward slash and an asterisk, and I finish it with an asterisk and a forward slash. That's just a full stop to end the sentence.
Yes.
Okay, so if I were to, let's see, let's shrink this down for a minute. You can tell by color rather than need. If I were to start writing here, this is my comment, and I went on to the next line and say that this is the second line. You can see that it's all in black script. It's not part of a comment. To make this a comment, I would need to do that.
Yes.
Okay.
I just didn't understand.
Yep. But the nice thing about this one here is that it's multi-line. So until I hit that command, once I start it with a forward slash and if I were to delete this, the entire piece of code turns into a comment. If I put it back in, and I keep writing on and on. So it keeps going and it keeps pushing it down, which is really handy because it allows me to type quite quickly a multi-line password. Or sorry, a multi-line comment. They're both acceptable. It would be absolutely fine to go forward slash.
Okay, otherwise I would have to use in every single line the...
Exactly, yeah, and that's kind of why you do it. I generally don't use a multi-line comment except for the very top if I'm putting in what this question does. If I have another comment down here, I just throw in a single line because that's all I need. Does that make sense? Because every year I get some students left off the code. I don't know why my code doesn't work, and they haven't realized that everything's green. Any other questions? No. Okay. Cool. So let's have a look here. We're going to go Java C strings 4, and then Java strings 4. It tells me it's an invalid password, and we can see that from our code because we have password. That's what the user's entered in, and this is what we want. Password. If we were to change this to match it, that's an O. Sorry, no, not. Now you can see that these are matching there. So if I were to go back and run this code again, or rebuild and then run, it now says access granted, although I realize I've misspelled access. Access. There. Make sense? Everyone happy with that? Okay. Now, that's 5. So what this question is going to be, I'm going to ask the user I'm going to do 2 variations on this question. And the difference between the original version of this and the variation is going to be 3 extra lines of code. And it'll make sense what those extra lines are really. So what this question is going to do is going to take a string in from the user, allow them to enter in whatever they want. Again, for this example, I'm just going to hard code the value, but if you're to put user input in, actually I'll put user input into this one. So we need our import statement at the top. And then if I'm taking user input, then I also need my scanner. My user input, that's there. I need to have a string to store the input. And what I want to do is I want to check, once the user has entered the string, how many times the character lowercase e occurs in that string. They say that e is the most common letter inside the English language, so that's why I picked that one. So what I'm going to do here is I'm going to prompt the user, so system.out.print ln enter a string. I'm going to take that in from the user, so s is equal to kb.next. Because we're dealing with a string, it's next line, not next int. And so now by line number 8, I have taken the string in from the user and I just need to process it. So my processing is going to be the same as what I've done previously. I'm going to have a counter, which will allow me to create a loop, which will go from the first element in that string to the last element in the string, which I can define by using .length. Inside that string, I'm going to get the current character. And once I've got that current character, I'm going to check, is that character equal to E? So here I'm going to have if C is equal to E. Now remember, we're dealing with characters here. So we have single quotation marks, and we're dealing with strings. I've got double quotation marks. And inside here, well then, I need a way of keeping track of the number of E's I've come across. So here I'm going to say num of E's plus plus. If I find an E, I'm going to retract it. That's one more. That's one more as I go through. Regardless of whether I find a character that is an E or whether I find a character that's not an E, I'm going to move on to the next character because otherwise my loop will never finish. And that's the end of my loop. And then after the loop, when the loop is finished, I'm then just going to tell the user how many E's they found. Okay. So there's my code. I'm going to throw all this in the OneDrive, so don't worry too much about getting it all typed up. I'm going to create my string. I'm going to ask the user to enter in a string. I'm going to take the string in from the user. I've got 2 counter variables here. The first counter variable is as I come across another character which is equal to E. And remember, lowercase e I'm looking for because we've seen from the Ascii table, uppercase E and lowercase e are in 2 different positions. So they're treated as entirely different characters. And my second counter here is just my normal loop counter. So this is going to be my character counter. And this is going to be my loop counter.
So if you wanted a capital E, you'd have to put an and C equals capital E.
Absolutely. So yeah, that's it. So if I wanted to check to see if it's equal to E or if it's equal to E, I have to do something like that. Absolutely. If I just wanted capital E, then I do that. Nope, down there. Again, for the interest of time and nicety, I didn't ask you to check for every vowel that's in the string, but that is a question I'd normally do. At some point, I'd ask the class, write a program that takes in a string from the user and tells me in total, I don't care how many A's or E's or I's there are individually, but how many vowels there are in that particular string. So we go through and we'll check. Does it match any of the 5 lowercase or any of the 5 uppercase? And we'd have ampersands between each. Actually, sorry, I was wrong there. It's not an and symbol in between it. It should be an or symbol. It couldn't possibly be the same character, or sorry, different characters at the same time. So if it equals either of these, well, then we're going to increase it. It will be impossible to equal both at the same time. Actually, let's leave that in. Let's leave that in there. It says check for upper and lowercase. If we find an E, we're going to increase the counter. We found another one, and we're going to move on to the next. Character. At the very end, we're going to print out what we've got. Does that make sense to everybody? So enter the string. Okay, so there's a string and there are a mixture of lowercase and uppercase E's in there. I can see here that there is 1, 2, 3, 4 E's in there, and I get 4 out as an output. If I were to amend that code and get rid of this, well, then it wouldn't count the capital E at the very beginning. So it only gives me 3. Does that make sense? Okay. Here's what we're going to do, because I think part of the reason why you've been so quiet is because you had the comfort of, well, he's doing all the typing today, and I'm going to flip that now and let you do some typing. I am going to put all of this code up into our OneDrive, and we're going to take a coffee break. It's just coming 1:45 now, so we're going to come back at roughly around 8. And I would like you to amend the code of the last program to allow the user not only to enter in the string, but to enter in the character they want me to check for. And we don't need to check uppercase and lowercase. Just whatever they enter in, that's all the only thing we're checking for. Fair enough? So grab your break, grab some coffee if you need some, or some fresh air. I'm going to put this up on OneDrive, and then after we've done that question, we'll have a look at the assignment.